Broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, RBCS New Zealand, RBCS Australia, Software Test Works, and Software Test Professionals, we welcome everybody today to this webinar on testing metrics. I am Rex Black. I'm president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. We have offices in the United States, New Zealand, Australia, and Sri Lanka, and partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with a measurable return on investment. RBCS has a team of international consultants to deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in computer science and engineering from UCLA. I'm also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. RBCS is presenting this webinar in partnership with Software Test Professionals. In addition to our ongoing collaboration on webinars and training, I will be the opening keynote at the Software Test Professionals Fall Conference on October 25th in Dallas, Texas. I hope to see some of you there. In addition, if you haven't visited their association website, make sure to check it out as well, www.softwaretestpro.com. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them at any time via your webinar interface. There is no need to ask for copies of the presentation. The presentation is on the web, www.rbcs-us.com. Go to the Resources tab, find the Basic Library page, go all the way down to the bottom, and there it is. There is no need to ask how to register for the free e-learning. Just by attending this webinar, you are registered. Check your email over the next couple days and watch the spam filter to make sure the notification doesn't get caught in there. You do have a limited amount of time to respond if you are a winner. And if you are having any problems with either the audio or visual components of this webinar, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online, or if you're dealing with an unreliable connection, please download the slides. As I said, rbcs-us.com, Resources tab, Basic Library at the bottom, and be sure to use telephone to connect rather than voice over IP. This afternoon, I made a bold comment saying, oh, we almost never have problems with voice over IP, and then right in the middle of the Q&A session, my audio driver on my voice over IP dropped, and people were left hanging for 4 minutes. So it does happen sometimes. Be ready for all eventualities. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not-just-for-profit company. So today's presentation is on testing metrics. Now, metrics are widely used, and testing metrics are also widely used, and typically to make project decisions. But what we see with a lot of our clients is they make some fairly easily avoidable mistakes, and that leads to misunderstandings and, of course, bad decisions proceed from misunderstood data. And I also see that not as many people who really should know do know how to use testing metrics to understand the capabilities of their software process and the quality of their products. So in today's webinar, we are going to look at how to do those things. Okay. Now, by training, I'm an engineer. I have a degree in engineering, as I mentioned, from UCLA. And so I like to manage with facts. I like to manage with reality. And, metrics let us do that. So metrics can help us understand where we are in the project. Metrics can help us understand the capabilities of our process and improve it. Metrics can help us understand what our product is like. There are various uses of metrics, and we're going to look at a number of them here as we go along. Now, let me start off with this question that comes up. Well, why metrics? I mean, couldn't we just, watch what's going on, sort of based on, well, or we think a lot of tests are failing, yes or no? Do we think we're seeing a lot of bugs, yes or no? Couldn't this all just be done kind of subjectively without any sort of measurement? No, not really well. You know, like I said, manage with facts. Don't manage with opinion. Don't manage with gut feel. Your gut will lie to you. Your gut will tell you things that sound reasonable that are actually wrong. My favorite historical example of this is Aristotle. Aristotle, you know, smart Greek philosopher from 2,500 or so years ago, said a number of very smart things, but one of the things that he said was that heavy objects fall faster than lighter objects. And for about 2,000 years, people believed him. And then at one point, somebody, I think it was Leonardo da Vinci or some other really smart Renaissance man, decided to climb up in the Leaning Tower of Pisa and drop 2 cannonballs of different weights off of the Leaning Tower at the same time. And he observed that they hit the ground at the same time as well. So much for 2,000 years of commonly accepted understanding of speed of falling objects. And, you know, I mean, the thing that's stunning about this is it is so easily disproved, and even in the context in which it was originally said. I mean, it's not as if Aristotle lived in the middle of the Midwestern plains of the United States or something, and a good cliff was hard to come by. I mean, he lived in Greece, for gosh sakes, you know. I mean, there's no shortage of cliffs. He could quite easily have walked up to a cliff with 2 different weight rocks and dropped them and observed that, indeed, they both hit the ground or the water or whatever was underneath at the same time, thus disproving his conjecture. So, you know, the moral of the story is don't trust your gut and trust data, trust measurements. Measure to know, because what sounds reasonable to you can easily be wrong. And in fact, it's the reasonable sounding wrong idea that's the most dangerous kind of wrong idea, because a wrong idea that sounds stupid is harmless. I mean, people just go, that's really stupid. You know, I don't believe that. But the wrong idea that sounds reasonable will have followers and will mislead people. So measure. Now, I believe this is particularly important for testing because testing by itself has no value. Just sitting in front of a computer and pecking away on it and observing whether what happens is what you expected to happen, that by itself, that has no value. That observation, the information gained, has to be connected to some audience that needs to know either that information directly, like which test passed and which failed, or some summation of that, some analysis or a summary or something like that. But that information has to get passed along to people. It's got to be generated, and it's got to be communicated, and it's got to be communicated effectively. You know, there's no good having potentially useful information and then not communicating it effectively. A tragic example of this took place a number of years ago. What was it, about 15 years ago? The United States space program Challenger disaster, when the Morton Thiokol engineers actually knew pretty much that the O-rings on the solid rocket boosters would not perform properly in the freezing weather that had taken hold of Florida that weekend. They attempted to communicate that information to the NASA managers and the Morton Thiokol managers to try to convince them to scrub the launch. Their communication, while the data was there in their presentation, it was not communicated effectively. NASA decided to go ahead with the launch, and at that point, the tragedy was ensured, and indeed the next morning the solid rocket booster burned through the brittle O-rings, brittle because of the cold weather, exactly as the engineers had thought it would, and spewed a jet of fire out directly onto the liquid hydrogen tank, blowing it up and killing all of the astronauts in the space shuttle, as well as destroying the shuttle itself and all of the other sundry parts of the booster that were there. So, you know, it's not enough to just have information. It's also important to communicate it. Now, this presentation is not so much about communication of results, we'd had a webinar on that previously, and we'll have another webinar coming up in summer about psychological aspects of test management, including communication of results. So I don't want to get too far afield, but I do want to point out that while we are focused on metrics here and effective creation of metrics, remember that communication is part of the puzzle too. So now when I'm talking about communicating this information via metrics, we can have various goals there. We could be wanting to just notify people, okay, here's a fact. We might want to enlighten people, to draw their attention to some aspect of the process or project or product that we think is worth them knowing about, and potentially also even influence them to try to convince them to take a certain course of action. You know, if you're trying to influence, notice that you have to first notify and enlighten. So that's sort of a cumulative type of situation there. Now, the metrics that I'm talking about, these can be part of your regular status reports, your test status reports of projects, or they can be part of some sort of periodic or as-needed analysis. I'm going to cast the net pretty widely in terms of metrics. Excuse me. Now, so let's talk. Let's start off by talking generally about how we can develop good metrics. Now, let's start actually first by looking at how not to develop metrics. Here's how not to develop testing metrics. Take whatever reports your test management package produces by default, spew them all out into some sort of JPEG or HTML or something like that, zip them up and email them to everybody on the project. Unfortunately, that is something that happens quite a bit. That is what I call the fire hose of data problem, where all sorts of confusing, irrelevant, and overwhelming data and detail is sent out to all and sundry, and of course no one even bothers to look at it because they have no idea what to do with it. They get used to getting a 5 meg zip file from somebody every day, and they just kind of go, whatever, you know, it's not even going to look at it. And I'm not saying that this is a testing sin specifically. This is a general management error that's made. Usually people who've been in management a while learn not to do this, but it is not unusual for people in their first few years of management to just think that over-communication is great, send out all sorts of data and, you know, be transparent and so forth. But people don't want that. People want to get what they need to get. So let's talk about that. How do you understand what people need to get? Well, first off, to develop a metric, think about the project, the process, or the product that you're looking at. And I'm going to get into a little more detail on that a little later, the distinction between them. But hopefully you get just generally from the words that make sense to you. So you got a product, you got a process, you got a project, and so you're doing something. And you have objectives for that. You have objectives that you want to achieve. Then ask yourself for any given objective, okay, what would it mean to be effective at this? What would it mean to do this efficiently? What would it mean to be elegant about the way I went about this so that it actually satisfied the people, the stakeholders who have an interest in these objectives and their achievement? Now, I want to briefly digress. I mean, let's just make sure I'm clear on what I mean by effectiveness, efficiency, and elegance. So effectiveness is, are you actually carrying out the objective? Sort of the brute force kind of thing. You got an objective, are you doing it? And or more accurately, really, usually, to what extent are you achieving it? Now, efficiency has to do, to some extent, with effectiveness, but more about cost effectiveness. It has to do with, given the resource, the time, and the money being expended on achieving this objective, are we doing it in a relatively lightweight fashion? Are we getting a lot of bang for our buck, I guess you could say in the colloquial phrase. Now, elegance has to do with, does this look graceful when we do it? Does it look like we know what we're about? Or is it like a sort of swirling tornado of chaos and we look like a bunch of bumbling idiots and maybe we produce the right result, but you know, it certainly doesn't look good. Kind of like the German Chancellor Bismarck's comment about those who respect the law and enjoy eating sausage should never watch either being made. You know, if people like our testing, it's not like we can just say, you know, well, stay out of the test lab and pay no attention to the man behind the screen. We don't want you to see any of this stuff. We're going to go off and do this, you know, without any visibility. Well, that's not the case. I mean, your testing tends to happen as part of a project, and the process is visible to people to a greater or lesser extent. So, you know, does it look like we know what we're about? Okay, so effective. How effective are we? How efficient are we? How elegant are we? Then, based on those questions, we then say, okay, well, how would we? What kind of metric could we put in place for this, and is it measurable? Now, in some cases, you say, you know, I actually can't answer this question directly, but there's something really related to it that I can answer that tells me indirectly the answer to this question. That's called a surrogate metric, and we'll look at examples of surrogate metrics later. So, now, having devised a metric, then you would set a goal or target for each metric. Now, I confused someone this afternoon with the word goal, so English wasn't his native language. He's like, well, what exactly do you mean in the difference between objective and goal? And to me, the objective is some general thing, and the goal is specific. But maybe target works better for you. So, you know, if you prefer the word target, think of target. And I'm going to give some examples of this. It'll help kind of illustrate what distinction I'm making. Now, based on that goal, one of the things that you might want to do is actually improve over time, get better at your effectiveness, your efficiency, or your elegance. So that's something that you might want to do over the long run. And again, we'll look at some examples of this as we go along. All right, let's start with one. This is a example of a project metric that we're going to derive here. So we have an overall objective for a project, typically with testing work going on. We want to find defects, right? We're running testing on a project. We want to find defects. And generally, we want to continue that until we feel fairly comfortable that we've found all of the defects that matter. And so what you tend to look for is a leveling out of the defect arrival rate, and also that the defects that you have been found have been fixed, and that you've confirmed them as fixed, and that's sometimes called convergence. We'll see an example of this later. I'll show you a chart where we look at you know, achieving convergence. You're going to look at the trend over time. Do the defects level out? Do the fixed defects intercept the discovered defects eventually? And we can say that we're done from a project point of view, at least with the defect finding objective. Now, in the long run, one of the things that you could do is you could say, you know, I look at the shape of my defect finding curve and the trend curve, and it's, you know, I find defects too late in the testing. I want to find them earlier. I want to find them right away. So that's an improvement that you might put in place, and then you could watch to see if you actually did shift the cumulative defect discovery curve to the left during your projects. And again, I'll show an example of this here shortly. So here's another example. Confidence. We want to have confidence when a project is kind of winding down and testing is concluding. We want stakeholders will want to have confidence that the product, if put into production, is not free from bugs, of course, because I mean realistically we can't guarantee that with testing. We can't find all the bugs, but we should be able to build up a level of confidence that says, you know, we feel pretty good about putting this in production. We think it's been thoroughly tested. Think the kind of problems that we would have missed are things that are probably kind of off the beaten path, relatively low risk. So we want to have confidence. Now, confidence is hard to measure directly, because well, there's two problems with it. One is, what are you going to do? You're like going to start, sampling the dopamine levels in stakeholders' brains while you're giving your project status reports. You're like, oh yeah, everybody's got a good dopamine release going there, so they're feeling good, and therefore they must be confident. If they have a dopamine release rather than a panic attack during test status reporting, then that's a sign of confidence. Well, no, you're not going to do that, because you're not going to be able to monitor that. And even if you could, that's actually the wrong thing, because you might very well be measuring false confidence rather than true confidence. So true confidence is based on an actual true understanding of where you stand. And so the surrogate metric that we typically recommend to be used for measuring confidence is coverage. Now, when I say coverage, this has got to be one of the most overloaded terms in software testing, right up there with test plan and test case. In terms of it, it can mean a bazillion different things. But anyway, when I say coverage, I'm talking not just code coverage, which is what some people mean. And in fact, for system testing, system integration testing, code coverage is not really the most meaningful thing to look at. It's good for unit testing and to some extent integration testing. But you get up into the higher levels of testing, like system test, system integration test, really you're more interested in requirements coverage, risk coverage, supported configuration coverage. If you've got major types of data that you deal with, data type coverage. So coverage is coverage of the stuff that matters, basically coverage of the things that your tests are based on. So this is a multidimensional kind of metric that we could look at here, but one of the dimensions of it, we could say from an effectiveness point of view, do we have any requirements that have known, identified, active failures against them? Because as long as that's the case, we can say, we know we haven't satisfied the requirements yet. And so our level of confidence should not be high until we've satisfied the requirements. So from a metrics point of view, we could classify the requirements as completely tested without any failures at all. So we are very confident that that particular requirement is met. Or we could say the requirement is it's been tested to some extent and we have found failures in it. So now we don't have confidence. That's sort of anti-confidence, since we know that there's a problem, but at least we're starting to know where we stand. And then there's the requirements that are actually completely untested, that we haven't tested at all. Of course, we have no confidence in those. We have no idea where we stand on those. So we can look at the percentage of again, the sort of green requirements, we could say, the ones that we're comfortable with and we've tested them where we think, okay, we're good here. The red requirements, which are the ones where we say, we've tested this and to some extent when we know we have some problems. And then there's the requirements that we're sort of in the black about, that we don't really know, that are untested. So we could have, percentage red, percentage green, percentage red, percentage black. And as long as the percentage of red and black is greater than 0%, then that's a sap on our confidence. Ideally, you'd want to say that before we get done with the project, we've hit 100% requirements are green status, in the sense that they've been tested and there are no must-fix failures. Now, in terms of an improvement, going from one project to the next, what you could do is you could look at historically, what percentage of requirements did go green or go red, at one point or another during testing. So that's stuff that came to you not done from a test point of view. And if you wanted to make the testing go faster, it's usually one of the major causes of the delay in the completion of testing is failed tests. If you want to make the testing go faster, then what you would do is look at ways to increase the number of requirements that are in good shape. And when you get the testing, when you get the release, which would be the same as saying reducing the number of requirements that fail on delivery. Generally, that's going to be through some sort of enhanced form of upstream testing, like unit testing or integration testing. Though it could also involve, of course, better requirements, better design, better code reviews. Okay, so we looked at defining metrics in general and looked at a couple examples of them. Let me go back to this theme of sort of in general, speaking in general for the moment, and then we'll go back and drill into some more specific examples here once I get this out of the way. But I think it's important to say something I alluded to earlier. Good metrics would be useful, pertinent, and concise. And this is true of testing metrics and quality metrics, any metric really. But now when I say useful, what I mean there is that it's connected to an objective. As I mentioned before, that you could look at this metric and go, okay, based on this metric, there's some decision I can make and potentially some action that I could take that would be driven by this metric. It's not trivia. It's not something you look at and go, oh, gee, isn't that curious, and then it's completely inapplicable to everyday life, like a Fibonacci series or something like that, where you might know it, it's a Sudoku or something, it might amuse you in some way, but it is not useful. Remember, engineering is about building useful things, and we've got to have useful metrics to help us build useful things. So, useful is part of it, but it's not enough to just be useful in the sense of connected to some objective. It also has to be pertinent, and what I mean by that is it's connected to an objective that the person looking at it cares about. That they say to themselves when they see that, yeah, that's something that matters to me. That objective and whether it's met, how well it's met, how efficiently it's met, how elegantly it's met, that matters to me. So it gets people's attention. And it also needs to be, your set of metrics needs to be concise. Again, the fire hose of data problem is something we really want to avoid, because you can have a lot of good information, but if you just go on and on again, the same objective addressed from 27 different points of view with 27 different metrics, you're going to lose your audience. Hit the nail once and on the head. Don't beat around the nail a million times with a hammer, is I think the important thing to keep in mind here. If you create these large sets of metrics, it's not only a lot of work for you, it creates a lot of measurement overhead, which is bad. You as a manager or as a tester, time you spend measuring is of course time taking you away from other things that you need to do. So I'm not saying that this isn't valuable, but I'm saying that this has to be seen as a balance. You spend the time on it that it deserves and no more. So don't create a lot of measurement overhead by having a huge number of metrics. And also remember, you will lose your audience. Attention spans are limited, especially amongst the more senior people. So say it once and say it right, rather than saying it a million times with a million different metrics that beat around the bush. Also, and I don't want to get into too much into psychology here, because again, we're going to deal with that in an upcoming webinar, and I think it's the July webinar that we're going to do to deal with this. There's a couple psychological things that you need to be aware of with respect to your metrics. Now, one of these is what's called cognitive dissonance. Cognitive dissonance is tendency for people to have a really hard time processing information that surprises them, that they are not expecting. And the other psychological thing that needs to be taken into account here is what's called confirmation bias. Now, confirmation bias is somewhat like cognitive dissonance. People tend to easily accept information that confirms what they already believe. They tend to look for sources of information and look for ways of interpreting information in a confirmatory sort of fashion. And what this means is that if there are different ways of interpreting a metric based on how it looks, don't be surprised when people don't interpret it the right way, but they interpret it in some way that's consistent with what their own personal goal for the project, product, or process is. So if we were talking about a project manager who's very much focused on a deadline, it's going to be difficult to make the case that the defect arrival rate, for example, is such that we're not going to hit that deadline. So you have to be ready to explain this stuff in great detail, logically argue your case. And the metrics are facts, but they're not. Often facts can have different sorts of interpretations put on them, and you need to be ready to help people put the right interpretation on the set of facts. Now, I was a little bit dismissive earlier about the automated test management tools, and I want to make sure that I'm clear about what I'm being dismissive about. I'm not saying that the automated test management tools of various sorts, be it Quality Center or any of the others, are worthless, not by any means. I mean, from a metrics point of view, they are very good at capturing all the sort of constituent data that you need for your metrics. At least many of them can be. The thing that they're not so good about is reporting. So, make sure that you, when you're thinking about how you want to present the metrics, rather than just gathering up the raw data that makes up the metrics, that you transcend the tool. So use the tool to gather up the constituent parts, things like traceability between the requirements and the tests and their status, traceability between the risks and their tests and their status, and the risks and the bug reports, and the bug reports and the test cases and their status, and all that stuff. You want to set up to gather that information for sure. Just understand that when it comes to actually reporting it, you're probably going to have to do a fair amount of massaging, often by dropping it into Excel. And yeah, the point of all of this is, enlightening, informing, not confusing or misdirecting. One of the questions that we ask when we do assessments is, this is of non-testing stakeholders, do you understand the test results in the form in which they are reported to you? In other words, when you get your test results reports, do they make sense to you? And does that understanding help you manage the project or process or product to success, whatever they're involved in managing? Now, it's interesting. We will get, as the answer to this question, more frequently than one would like, for sure. Either, no, I don't understand the results based on the reports, and of course then, no, I can't, that doesn't help me manage. Or you get, yes, I understand them, but no, it doesn't help me manage. Now, you might say, well, that's weird. If they understand them, it shouldn't help them manage. Well, this gets back to the useful and pertinent problem. If we're giving people information that is not useful, or maybe it's useful but not to them, so it's not pertinent, then that's not going to help them manage. So it's got to be useful and pertinent, and it has to be understood. So make sure that that's your goal, what you're striving for. Excuse me. Now, in terms of how to present information, again, we had a separate result, reporting, test results reporting webinar, and I don't want to rehash the same ground. If you're curious about this, and you didn't catch it, go check it out on the digital library. But just to say briefly, in terms of presenting metrics, one of the options is to present a snapshot of status at a moment in time. And this is typically something like a table or just a single number. It's like, okay, this is our measurement right now. When you're looking at your dashboard on your car, a lot of the gauges there are snapshots of current status, of speed and current amount of gasoline and so forth. So they are just, here's where you stand right now. And when you're driving a car, that's pretty much what you need to know. You don't really need to know, efficiency and okay, what's my trend in terms of mileage and so forth. I mean, not in real time, because that's not pertinent to safely operating the vehicle. But in some cases you do need to know trends emerging over time, and so there are plenty of metrics where you do present them as a trend chart. So a trend chart is any chart that has as its typically the horizontal or x-axis is time. And the vertical axis on which one or more data points are plotted is defects, or the number of past test cases, or the number of requirements that are green, red, or black based on the scheme that I mentioned earlier, that kind of thing. Now, a trend chart is great because it can show you, where we're headed, and that's very useful, but it doesn't tell you why anything is happening. So another type of chart that you might create is a causal or relationship chart, like a scatter plot, check relationships between two variables, or Pareto analysis to look for defect clusters or something like that. So you really want to think about what's the right way to present the information. Now, as I said, I talked about this in the results reporting webinar. If you're interested just in general, a guy named Tufte, Edward Tufte, has written this whole series of books. That's Tufte, T-U-F-T-E, on good graphical displays of information of various sorts. In fact, the first book is called just that, Graphical Displays of Quantitative Information. In spite of the extremely dry title, is a very engaging book and is truly perspective altering. You'll never look at another presentation of information the same way again after you read Tufte's books, so I recommend those. Okay, so now let's go back, kind of come back around to this question of some metrics and types of metrics and examples of each type of metric. So let's start out with process metrics. So when I talk about a process metric, we have a lot of processes in testing. You've got defect management process, you've got the test environment configuration process, you've got the test case, test data, et cetera, creation process, you've got quality risk analysis process if you're doing risk-based testing, you've got an estimation process, results reporting process, and so forth. So we can identify all these various processes that we have, and then we can say, well, let's put some metrics in place to see how effectively, efficiently, and elegantly we are carrying these processes out. And of course, based on that, we might decide to institute some improvements. Now, if you were to have ever had a assessment from us, from RBCS, you know that we use a framework called the Critical Testing Processes, or CTP framework, and we specifically use metrics in our assessments. As again, manage with data, right? We want to manage with data. So certainly when we're making process improvement recommendations, we would have a lot of process metrics, and it depends on the size of the assessment, but certainly we can have dozens of metrics that we can look at. Too numerous to list. So this is, I think, a good thing to do. Have some process metrics, identify your critical testing processes, put some effectiveness, efficiency, and elegance metrics around those, and measure. And then if you find that you fall short of industry averages or just where you want to be, then set some goals for improvement and make those. So examples. Well, wait, before we get to examples, let me cover one other thing. So just to put this in context, I talked generally about good metrics, and just to be specific about process metrics, you want to make sure that you look at, what are our critical testing processes, and make sure you focus on the critical ones, right? I mean, looking at stuff like does the phone system route phone calls to the testers efficiently? That's probably not top on the list of things that get in the way of you doing your job. So critical test processes, and then define the key objectives for those. Now, those can be things like finding bugs, right? I mean, so we look at the bug detection overall is important for testing. So do we find bugs? And do we find the important bugs more heavily than the unimportant ones? Do we reduce quality risk? Do we build confidence? Do we provide useful, enlightening information? So, define your objectives, decide the effectiveness, efficiency, and elegance questions that you need to be able to answer to know, how well these objectives are being met. Create your metrics to address those questions as mentioned before, and then set your goals. Either, ideally what you would do is benchmark yourself, like say, okay, here's where we are now. And then you'd say, okay, where do we want to be with, relative to industry averages and other kinds of things. And then crank it up. Look for ways to improve your process. So now we'll get some examples here. So let's start off with bug finding effectiveness. So typical objective of the testing process overall is finding bugs. So the effectiveness question that we can answer is, what percentage of bugs do we find? Now obviously not 100%, but we want it to be most. So the metric that we would look at there is called the defect detection percentage. You can see it's defined here. DDP is equal to the number of bugs detected divided by the number of bugs present. So if we're talking about testing, and testing in the sense of it's the testing that happens right before we go out the door, then we would say, okay, we look at the number of test bugs, divide that by the number of test bugs plus the number of bugs subsequently found in production. That's our DDP for testing. Now, obviously, you need to wait some period of time after the testing is over and the product is in production before you start to measure the production bugs. On the day you go live, your DDP is going to look real good. It's going to be 100%, but you have to give it some amount of time. Typically, there's some characteristic period, say 90 days, 30 days, 2 weeks, so it depends on the adoption rate of your users, during which 80 or 90% of all the defects that will be reported are reported. So for a given release, you can measure the DDP by just waiting some number of weeks after the release and then counting the production bugs. Steady state, for a lot of our clients, they measure the DDP on a rolling basis using data from the last year. And what tends to happen there is that tends to work out pretty well. If you look at all the bugs found by testing in the last year and all the bugs found by production in the last year, then that tends to be a pretty good approximation, because it tends to include a certain number of test bugs for which no production bugs have been filed yet because it's a new release, but it also includes production bugs for which the test bugs are no longer being counted because it's an older release, so it kind of comes out in the wash. Now, what should your goal for this be? Well, a typical number when we do assessments is about 85%. Some teams do better. Some teams do a little worse. We've certainly seen clients that have gotten this as good as 99% on a fairly consistent basis, though that is not easy to do. Now, not only do we want to find bugs, typically we also want to find the most important bugs. So, are we finding more important bugs than less important bugs? This is a question of, are we focused? Are we effectively focusing our effort? So the metric that we can use here is looking at the relationship between the defect detection percentage for the critical bugs, however we want to define those, the ones that are important, versus the DDP for all bugs. The DDP for the critical bugs should be greater than that for all bugs. In other words, we find a greater proportion of critical bugs than we do overall. So that relationship shown below should be true. Now, what we tend to find with clients that are not practicing risk-based testing is that actually it's the other way around. So, risk-based testing is a real good way of making sure that you're focused on the right stuff. I've done a number of presentations on risk-based testing, so I'm not going to go off into that realm here, but if you're interested, there's at least one recorded webinar that's directly pertinent to risk-based testing that you can go and access. And in addition, there are a whole bunch of videos that you can access on the digital library. So if you go to the rbcs-us.com page and select that resources tab in the upper middle of the page, you'll see it pulls down a list. Digital library is one of the things that you can access off of that list. And there's probably about 3 or 4 hours of videos out there about risk-based testing and how to do it. So I'd encourage you to go take a look at those. Okay, so project metrics. So we talked about process. The process metrics, when you measure a process metric, you're like, okay, I'm going to measure the capability of my process in a way which is transcending projects. Now, in project metrics, we're saying, no, I want to see where we are in terms of testing for this project, usually with a goal towards getting done with the project, though it also can mean, lessons learned from this project that I should apply to subsequent projects to do them better. Again, in certain process assessments, critical testing process assessments, we look at how effective these are. And like I said, the question that we asked the stakeholders about Do you understand the test results? Do they help you manage the project to success? Now, project metrics are the ones that are most commonly used from a testing point of view, and unfortunately, they are often overloaded. So I'll give you an example of that. Let's say that we're looking at the percentage of test cases that have been run, and the percentage of test cases that have been passed, and the percentage of test cases that have been failed. People often try to use this as a product quality metric, and here's the problem with that. Certainly, if you've tried to run your tests and 50% of them are blocked, only 50% of them can be run, and of that, you've got 40% failed and 10% pass. That's bad. I mean, you got 40% failed tests, 50% blocked tests, and 10% pass tests. You can say, yeah, the quality of this product is bad, almost certainly. Though it could mean that the test environment is just set up completely wrong, and none of the data is loaded properly. So it could actually be telling you that your test process from a test system setup point of view is broken. But even if we assume that that's all correct, the tests are being run correctly, okay, we can say we know bad when we see it, but how about good? I mean, if we say that 100% of the tests are run, 90% pass, and 10% fail, is that good or bad? Depends. Depends on which 10% failed. It also, just because 100% of the tests will run doesn't mean that we should have a high level of confidence in the product, because that's not coverage. Coverage has to do not with what percentage of tests have been run. That's a self-fulfilling prophecy in a sense. It's circular logic. Coverage has to do with what percentage of the test basis has been covered. Now, when I say test basis, I'm referring to that which the tests are based on. In other words, what we should test. How much of what we should test have we tested? Percentage of tests run doesn't tell you anything about how we're doing in terms of coverage. I mean, if our tests are perfectly set up and they're covering all the right things, and yeah, I guess it does tell us something, but that's certainly, there's no guarantees of that sort of thing. So be careful of overloading these project metrics. This is one of the big mistakes that we see being made. Excuse me. Here's a example of a project metric, and I just want to go through this quickly. And those of you who have seen the results reporting webinar, you're kind of familiar with this. And if you haven't, I'll just say, go check it out on the digital library. All the recorded webinars are out on the digital library, and you can find them very easily. Anyway, this is a trend chart. It's a trend chart because this axis down here is time, dates specifically. We have 5 data points that are being plotted on this graph. We have this one, which is the cumulative or total number of bugs opened on a daily basis. Each data point there is a day. And this is the total daily close. This cumulative number of bugs that are closed really should probably be resolved in the sense that it also includes deferred defects. So as we can see, we're finding defects and they're getting fixed. This is marching along behind. It's cumulative. That's why it keeps going up. We're at about 1,200 defects found and about, it looks like a little over 1,000 fixed. And we believe we're going to hit about 2,000 defects total by the project end date of March 21st. So that says there we expect this to go up, flatten out, and hit there. At the same time, we expect this curve, the cumulative close curve, to come up and intercept sometime on or before the 21st. And that's when I was talking about convergence before. That's what we expect to see. Now, those 2 data sets are graphed against this axis over here. There are 3 other data sets that are graphed against this axis on the left. One of them is the average daily closed. So the average daily closed is you take the number of bugs that were closed on a given day, you add them up for that week, the 7 days of the week, you divide by 7. That's the average daily close for that week. And then we have the average daily open, which is shown as the minus sign here. So the close is the plus, the minus is the open. And that's the same thing. We just add up the number of bugs opened on each day, the week, divide by 7. That's the average daily open. Now, the average daily backlog, this is the 5th data point. The daily backlog is the cumulative found here, this one, cumulative open or total daily open is the chart label, minus the number resolved or total daily close, the chart label here. So if I take those, I take this minus that, then that gives me the backlog for the day. I can add up the backlog over the course of the week and divide by 7, and that's the average daily backlog. Now, I think that it's interesting to point out here, you know, one of the things you want to do in presenting metrics is draw the audience's attention to what you want them to think about. And you know, if you just look at this total daily open and the total daily close, they don't really seem to be that divergent. It doesn't seem like you've got that big of a backlog. But in actuality, you have an enormous backlog here that loomed up to as high as 225 during one particularly bad week. And so this draws people's attention to the fact that, oh boy, the backlog really got out of control. And the thing, backlog is one of these vampires, like invisible vampires on a project, because you know, when you have a high backlog, you tend to get a lot of defect reports getting kicked back after weeks of being in the backlog with, hey, I can't reproduce this anymore against the latest version. Could you please try this again? That, of course, is inefficient. You also get a high rate of duplication because the testers, while they have a sneaking suspicion that this problem that they're looking at has been reported at least once before, they can't find it because it's lost in the backlog, and so they report another one, and that, of course, gets frustrating for everybody. They're like, hey, you've got 2 of these out there. We've dealt with this one already, and the developers get frustrated, the testers get frustrated. So backlog is bad. So, you know, this is using this project metric to call attention to something that's potentially problematic. You know, one of our objectives from a project point of view is not just to find defects, but also to find them in a way that they get quickly managed. This is overall defect management. Okay, now product metrics. So when we talk about products, we're talking about measuring quality and the residual quality risk in the product, and let us know, you know, like where are we in terms of the product? Is the product ready to go? Is it not ready to go? You know, what should we be worried about? Now, there's again many different examples of these that can and do exist. Now, I want to point something out that's probably starting to dawn on some of you, which is that we can use the same or related metrics as a product metric, a process metric, or a project metric sometimes. And that is certainly true. Just be careful when you do that. If you're going to try to reuse it, make sure that you're not just going, oh, I get a single metric and I can use it for all 3. I mean, it really does. You know, you want to start from the objective, as I said. Go to the question, define the metric, and if you find that that leads you to a metric you're already using or very close to one you're already using, and you can derive that very easily, certainly go ahead and do that. But you know, do be careful, because we do see, as I said before, a lot of overloading of metrics, and people thinking metrics are telling them about product when they're actually only telling them about project, and you know, other variations of that theme. Definitely, we want to have product metrics as part of our test status reports and dashboards and so forth. This is the thing that tends to be missing, and this is one of the reasons why non-testing stakeholders tend to be very dissatisfied with test results reports, is because they often do not feel that they've been given proper insight into the status of the product. They feel like they have a lot of tactical information about the test project that is underway, but then they're like, hey, I don't need to manage that. That's what I've got a test manager for. I need you to help me extract wisdom from this. So let's look at an example here. This chart shows risk, residual level of risk. I could just as easily do this for requirements using that same green, red, black code that I was talking about earlier. So let's think about this in terms of risk. So the green region, those are the risks where the tests are run and pass. All the tests are run and pass. So in other words, we have complete risk mitigation here. There are no known must-fix bugs. Every test that we had planned to run against this risk has been run and it's passed. So the risk is as mitigated as it's going to be. We're going to put it in the green category. And again, we could do this with requirements too. Red means that it's a risk for which we have run some tests and we've got at least one test that fails, or we've got at least one known must-fix bug that was identified by a test that's not a test script or test case-driven test, like an exploratory test or something like that. And then black are the other risks. We haven't found any problems yet because, you know, if we had the risk, it would be in the red category. But we also haven't finished testing it, so we're still kind of in the dark about it. And again, this can be done with requirements or anything else that we're trying to cover. Now, in terms of the mechanics of this chart, you need traceability from your tests and their results back to the test basis. In this case, it's the quality risks. And you need traceability from your defect reports back to your test basis. Again, in this case, the quality risks. Some people this afternoon were like, oh, you know, where do we find more details about that? If you are on our mailing list, you got a newsletter yesterday or the day before, depending on where you are in the world. And the featured article had to do with risk-based test results reporting. It was co-written by myself and Nagata Atsushi of Sony, based on his experiences and my experiences working with him and to help him do this, to put risk-based testing in place and put risk-based results reporting in place. And there's some very interesting stuff there. So check out the article, featured article in that newsletter. If you're not on the newsletter subscription, just wait a few days. The newsletter is going to be posted on our newsletter archive on our website, and you can go and find the newsletter and find that article and click through to it. That article was in the November-December edition of Software Test Professionals as well, so you can go to the Software Test Professionals website that I referenced earlier and take a quick look at that too if you want. So there's a number of ways to find that. Oh, okay, so now back to this. This chart is a sequence of pie charts, so let's be clear about how this works. At the beginning of the test execution, of course, the pie chart's all black because none of the tests have been run, so you haven't covered everything. As you start to run your tests, what will happen is that some of the tests will fail and some of the tests will pass, and eventually all the tests for a particular risk will have been run, and that risk becomes green. As the tests fail, of course, the risks are basically going out of the black into either the red category or the green category, depending on whether all the tests pass or one or more of the tests fail. So what's going to tend to happen earlier in the test effort is that the red region is going to grow disproportionately fast, especially if you're doing risk-based testing, because you're going to run tests that have a higher likelihood of failing earlier in the project. So the risks bleed disproportionately from the black into the red region, and it creates the appearance of the red region like chasing the black out. And then what starts to happen is that risks start to migrate from the red region as the problems are being fixed, and also from the black region as lower risk stuff that doesn't tend to identify problems passes. And so then you get the green chasing the red out, and you get to what we see over here where it's almost all green. And at any given point, we can report to the project team, okay, these are the risks that are in the black, and these are the risks that are in the red. And if people are, say, if the project team says, you know, we'd rather just accept those risks as unmitigated risks rather than continue the testing, then you've reached that balancing point between, you know, the level of risk and the level of other level of quality risk, excuse me, and the level of the other kind of risk posed by things like continuing the testing and so on that would exist. So this actually allows the project team to make an informed release decision rather than, you know, basically what they usually are doing is trying to guess out of myriad defect results reports and test case results reports what current status of the product is. And it's not quite as bad as how they used to do predictions of the future in the ancient times. If you read Herodotus's histories of the Greek wars with the Persians, you'll know that you would sacrifice a sheep and then look at its entrails to try to figure out what was going to happen. The Chinese had something similar where they would burn the shell of a tortoise and crack it and look at the way it cracked and say, oh, well, this tells us this or that. So it's not quite sheep entrails or cracked tortoise shells, but from the point of view of being a transparent process of prediction, a lot of project managers, I think, feel kind of the same way about test results reporting as it currently or often happens. So what I'm suggesting here is that we change the conversation in terms of, not just talking about project status, but let's talk about risk and let's talk about requirements coverage and those sort of things. Okay, so to wind down the main presentation, move on into Q&A. Let's just draw some conclusions here. So I hope that you can now see, if you hadn't already seen before, is that metrics are very useful for our point of view of measuring, understanding, and managing the overall process, the test process, software engineering process, or the status of the project, and also our product attributes. And in fact, I would say that test metrics are indeed essential to having a fully enlightened understanding of what's going on. That anything that's not informed by data is maybe a good guess, and certainly the longer people have been around, the more they're able to make good guesses based on subjective information. But why rely on that? Set up a set of metrics, a small set of metrics with a lightweight measurement overhead. If you find that something's too difficult to measure directly, look at ways of having surrogate metrics for it. Educate stakeholders on how the metrics work and what they say, and make sure that the metrics are defined from a top-down perspective, starting with objectives rather than starting with the metric itself. And use the metrics to manage, use the metrics to enlighten, use the metrics to notify. Manage based on data, manage based on facts, rather than just opinions. And don't just manage, improve. You can't make rational process improvement decisions unless you're looking at data. We recently helped a client make some pretty momentous efficiency gains, or at least get started on the path to make some momentous efficiency gains based on some metrics that we looked at in terms of defect data. They knew subjectively they had a problem with their defects, but it wasn't until we sat down and measured it that they said, oh, wow, that's a tremendous amount of money. We really should do something about that. Okay, so as usual, I will put the advertisement up here while we go into the Q&A world. Now I'm going to undock my question panel here, because this is always something of a challenge. We had a question here from Irina. Good to see you here again, Irina. You ask, how are metrics related to KOI, or key operating indicators, please? These acronyms, KOI for key operating indicator, KPI for key process indicator, and so forth, these get used in a lot of different ways in organizations. So I worry a little bit, Irina, that the way this is used in your organization might be inconsistent with what I'm about to say. So I would take this into account. So, basically a KPI or a KOI really it's the same as the metric that I was talking about. What makes it key is the fact that it should be related to some critical thing. This gets to the pertinent, right? There's some objective, and it really matters to us, and so that makes it key. As far as the operating or process element of it, this is going to be it's looking at the process, or looking at the operation and assessing how we're doing. So they tend to be, though it's hard to say uniformly, again, because of the variation in usage, these tend to be more process metrics than project or product metrics. So a KPI or a KOI would tend to be a process metric that has a clearly definable relationship to some sort of critical objective that relates, again, to the process. Let's see. It's got some email questions here. Excuse me. What kinds of metrics mistakes do you see people making? Good question. There's certainly a number that we've seen. Confusing process capability metrics with individual capability metrics, probably the most scary problem. And of all the mistakes, really the most corrosive is this one, because here's how this works. You've got some sort of process capability metric, like finding defects, and this is measuring the overall capability of your software testing process. It's a defect finding operation. It's not measuring the competence of your individual testers, but we've seen situations where people's performance evaluations get tied to these process capability metrics, and they feel like, hey, I can't control the process. I can control my little piece of it, my contribution to it, but there's bigger pieces that count for a lot more of the behaviors than what I do. And that tends to just be a morale killer. It basically turns performance evaluations into some sort of game of chance, which is completely unfair and will not result in the kind of behavior that you would want. Now, even if you do try to get this sort of right, you get to another metrics mistake, which is rewarding people based on metrics in a way that results in suboptimal or counterproductive behavior. Like an example of that is, we had a client once where when they were moving from one level of testing, from system testing to system integration testing, basically, the only metric that they looked at in their exit criteria for the system test was what's called the defect fix percentage. What percentage of the defects found had been fixed? This actually had a very bizarre result, which is that the project managers would try to create situations where there would be a large amount of duplicate defect reports that were filed, because then when they closed out a single problem, they could actually close more than one defect report and mark it as fixed, so having a disproportionate impact on the percentage of defects that had been fixed. And one project manager boasted to me during the assessment interview, like, oh yeah, we collect these duplicate defect reports, and then when we get to the cutoff day for going into system integration tests, we haven't hit our 90% target, we just fix a bunch of the duplicate defect reports and it shoots us right over the edge. Basically what he's saying is we ignore the priority of the defect reports in our fixing. We focus on fixing reports that are duplicated, regardless of their importance, because it scores us more points on the defect fix percentage. Now that's completely counterproductive behavior, but it's exactly what you would expect if you incentivize a project manager based on release dates, and you can't blame the project manager for doing it. The incentive was created by management, and you cannot blame someone for responding to an incentive, even if it's plainly obvious that responding to that incentive is actually counterproductive to the organization. Unbalanced metrics that don't show a complete picture is another mistake that is often made. So, again, think about this. Have I addressed all of the objectives? If you're just focused on one or two of the objectives, and you've got objectives for which there aren't metrics, then do not be surprised when that doesn't turn out well, and those objectives that don't have metrics don't get achieved, because the management rule of thumb, that what gets measured gets done, is got as its corollary what doesn't get measured doesn't get done. So, if you don't have balanced metrics that address all the important objectives, then expect that the objectives that aren't being measured will not be achieved. Another common metrics mistake is confusing correlation with causality, or assuming that there's correlation, or assuming causality. This is, anybody who's ever been through a statistics class will have heard of this from the statistics professor, who will have bemoaned this extensively. But basically, just because you see something happen, and right around the same time you then see something else happen, it does not mean that the thing you saw happen first caused the thing you saw happen second. They could be completely unrelated, random chance, or they could be correlated to something else, which is the real cause underlying them. And there are any number of things. I don't want to get into a long discussion of this, but before you make any assumption about A causes B, then there are some statistical tests that you need to be able to do to prove that that's actually right. And then finally, with metrics, we see a mistake of this lack of consistency and constancy over time. These metrics programs get started. People don't have a lot of staying power. They put metrics in place, but then they don't go with them over the years that it takes to see improvements, and they just kind of give them up, and it's the fad of the month, which is not by any means unique to metrics programs or to testing, but it's certainly it's a common problem with metrics. So I got a question from Atsushi, Atsushi Nagata, my co-author of the risk-based testing article. Good to see you online. I hope you're having a fine day in Tokyo this morning. So question, how many metrics is reasonable or useful? Some guideline. Oh boy. Well, let's see. So, I mean, I think my general rule of thumb in terms of testing dashboards is, for project status, is to try to keep it like 4 or 5 if you can cover all the important project related objectives in that number, and that does seem to work. If you've got you can look at where you are on defects, you can look at where you are on test progress, you can look at where you are on coverage, and those main metrics really ought to suffice. In terms of like process capability, I mean, you have 12 critical testing processes, and so you've got to be a little more fine-grained on that. But then there's also the what are you going to report too? I mean, that's another thing to think about is when we do an assessment, we can look at anywhere, I mean 20, 30 metrics across those 12 critical testing processes. But that's not something that we would say you should regularly report. Usually we have sort of a coarse-grained kind of test process effectiveness and efficiency metrics, that 2 or 3 of them that are being reported regularly in terms of things like level of coverage and product quality in the field and the defect detection effectiveness and efficiency. Those things would be sufficient. So yeah, try to keep it small. I mean, I think in terms of stuff that's going to be like part of a dashboard and regularly reported, you're probably shooting for 3 or 4. Well, we did a project for a client fairly recently where we went through and set up a set of metrics, and yeah, I mean, we must have identified a good 40 or 50 metrics, but in terms of the stuff that was going to be regularly reported at a senior level, it was a pretty small number. Let's see. Jason asked, do you have any special points or suggestions for Agile Scrum project testing? Boy, this is a point of contention to some extent for me, Jason, because, well, it's a discussion that I've had with people in Agile before, because there's some of the Agile teams have this rule about don't track defects and don't track test status during sprints. Only track defects that are going to get carried over into the next sprint, or don't track your tests if they've passed or failed until you, unless they're going to fail into the next sprint. A couple points to debate that. One is, even when we've seen teams where they're following this rule, and I'm not talking about dysfunctional Agile teams either. I'm talking about places where I would say that Agile is working very well, and they've got the data to prove it. Those bugs and the tests are actually being measured. What they're being measured in is that individual testers have lists, spreadsheets, and Word documents and those sort of things where they're using to keep track of this. And the thing is that that's not aggregatable, and that's not analyzable. You can't get any sort of insights or big picture out of that. And so that brings me to the next point. This is my argument with some of the Agile people is, if you want to improve a process, you've got to measure it. You cannot make rational process improvement decisions on unmeasured processes. And it's interesting to me that at the same time that the Agile folks are doing something that I think is very commendable, which is resurrecting unit testing and unit test coverage as a real engineering art form where they're doing it right and they're measuring it and they're setting goals and stuff. At the same time, to be instilling processes that basically blind us to defect management in the software engineering process, which is one of the most critical software engineering processes there is really kind of ironic. So my suggestion to you, Jason, and I realize that you're going to be, spitting into the wind to some extent on this because you're going to get the three-letter firing squad directed at you, or three-word firing squad directed at you, which is namely, that's not Agile. But, regardless of that, you can't improve it if you don't measure it. And so I'd say make the case, we need to have some repository. Now, again, this can be lightweight. Measurement, I'm talking about measurement overhead here, as mentioning before. It does not have to be heavyweight to be a valid measurement. It just has to be a valid measurement. It has to be taken consistently, the same way, every time it's done. It doesn't depend on the person doing it to what the measurement would be. But, we need measurements. So anyway, I'll get off my hobby horse here. Best of luck with that, Jason. As I said, it's funny in Agile because there are some things such as unit testing and unit test coverage where they're just I just couldn't be happier with the trends that are playing out. But then there's other stuff like defect management where I just struggle to understand the logic behind the argument that we shouldn't track defects because that's quote unquote too much work. Let's see, a comment from Matsushi. Thank you very much. Quite welcome. It's good to have a discussion with you in these evening webinars. I enjoy evening my time, morning your time. You're sipping coffee, I would assume. Let's see. What metrics, Rajesh asks, what metrics can be used for defect prevention and how? Well, so here's something interesting. Now, this again involves having a robust defect tracking process in place. If you track your defects that are found in requirements reviews, design reviews, code reviews, unit testing, integration testing, acceptance, system testing, acceptance testing, and so forth, and you can look at the defect detection percentage in each one of those, what you want is what's called 100% phase containment. What that means is that every defect is detected and removed in the same phase in which it was introduced. And you can measure that. In terms of what you're actually going to get, it's going to be less than that. No organization gets to 100% phase containment, but that you can strive for that. Now that reduces one kind of defect introduction, which is the sort of knock-on effect. The bad requirement causes multiple bad design decisions, which then cause multiple bad code decisions. Now, in terms of defect prevention in the classic sense of we increased our process capability and we introduced defects, what you can look at here is defect density, and the defect density on a project-by-project basis. If we are getting better at preventing defects, what we can do is we say, you know what, based on function points or the number of developer hours or something like that, we would expect to get X number of defects on this project. We want to reduce the number of defects each project by 10% from what it was in the project before, and gradually reducing our defect introduction rates. And those metrics can be measured over time. It's a long-term process, but it is indeed something that can be measured. And I would point out, this would be something that would be really good in Agile, because one of the things that you're supposed to do in Agile is learn and get better from one sprint to the next. You do retrospectives, hey, we could learn this, we could learn that. If you were to measure the defects that were introduced on a sprint-by-sprint basis, normalize that by effort or user stories or whatever, and then you could actually measure and plot defect density going down, defect introduction rates on a normalized basis going down. But notice that you would have to measure not only user stories, and of course the size of the user stories would matter too. So they use those Fibonacci series that you might measure, you might normalize by that. But you'd also have to measure the defects. And this would be a real good way of saying, hey, are we actually getting better? So Todd has a question. We expect you will say it depends, but are there any commonly used metrics that you would recommend? Well, I'm not going to say it depends. Actually, there are a lot of commonly used metrics that I think are quite useful. So for example, I mean, if you have read my books, Managing the Testing Process or Advanced Software Testing Volume 2, which is the one about test management, you'll have seen, or critical testing processes for that matter, you'll have seen some of my kind of favorite metrics. You'll have run into them. Mostly project metrics in the case of managing a testing process, so there's some process metrics in there as well, and product metrics. But anyway, you know, if you refer to those books, you'll see them and described in more detail. And all the spreadsheets that were used to produce the graphs and charts in those books are on the RBCS website, so they're free to download. But you know, for example, defect detection effectiveness, I think, is one of the or defect detection percentage is another euphemism or a synonym for it, which I used in this presentation. You know, how well our process detects defects. I think this is just a classic metric. Almost every test team has as one of its process objectives finding defects, and this metric is really a great one. You know, that risk coverage or requirements coverage, the pie chart that I showed you earlier, I think that's also a very good one because, you know, this gets directly to the question of what level of confidence should we have, what's the residual level of risk, and that's something that definitely should be measured. So I would say, you know, there are a number of very common metrics that are out there, and as I said, you know, if you read either of my 3 books that are management focused, that'd be Critical Testing Processes, Managing the Testing Process, or Advanced Test Management, or Advanced Software Testing Volume 2, you'll see a number of examples. Let's see, question from Craig Harris. Once the metrics to be reported, highlighted, et cetera, are decided upon, is it simply a matter of tuning the test tools? Example, Quality Center ClearQuest automatically churn out the design metrics on demand. Well, I would sure hope so, Craig. Yeah, I mean, once you've come up with your quote-unquote dashboard, it's sometimes called, and we've worked with some clients to do this. What you want to do is automate that so that all the data gets fed into the appropriate, the source data gets fed into the appropriate repository or repositories, and then on a periodic basis, that data is pulled out and used to create the dashboard. I mean, either directly in the tool like Quality Center or indirectly, like pulled out of Quality Center, dumped into a spreadsheet, and then updated that way, and then the results created. And you know, there's certainly many ways to go about skinning this cat, but you definitely want to do so. It should, you want, as I said in the presentation, you want to reduce measurement overhead, because if this becomes an enormous drain on your time, it's distracting you from other things that you ought to be working on. Now, the more typical way that this becomes management overhead becomes a problem is people are producing reports that are neither useful nor pertinent, and that's this stuff's just getting tossed directly. No one's even bothering to look at it. But even if you do have stuff that's useful and pertinent, if it's a major pain in the neck to produce it and it's got significant overhead costs, then that's a problem right there. Your cost of producing your reports, once you get them set up, should be pretty limited. Let's see, a question from Nupama. In a few projects, the metrics tend to change for each iteration for a given test in agile environments. How can we ensure that we are using the right metrics? That's an interesting observation. I've not actually run into that. Maybe I'm misunderstanding the question, but the thing that I've seen with Agile is a tendency to, in my opinion, as I expressed before, under-measure testing from a project, process, and product point of view. I have not seen this dysfunction that you're referring to of every sprint has a new metric. I mean, obviously the test basis varies from one sprint to the next, because your test basis, at least for system testing, is going to be the user stories, and that's going to change. But you know, we can measure coverage of the user stories. We can measure defects found per user story, weighted on size, as I alluded to a few moments ago. I mean, it seemed like you can define a constant set of metrics and keep those. And if there's a lot of redefinition of the metric, that's kind of curious. Atsushi makes a good point here that I should mention. He brought this up in passing, but I should mention, and I am reminded by something that he mentions in the comment, that the approach that I'm describing in terms of generation of metrics there is derived from Victor Basili's what's called goal question metric approach. And there's plenty more information about that out on the web if you want to take a look at it. So I would encourage you to do that if you're interested in it. I was trying to pack a whole lot of stuff into a fairly short time, so I didn't want to get into a long digression about Basili and how he came up with this. Another email question here. Can organizations use process metrics to measure their efficiency? How much money do you think organizations can save by optimizing efficiency? Answer is absolutely yes. I mean, you know, you have these objectives, you set efficiency metrics for them, and you can then improve that. I mean, to give you an example, I alluded to this in the presentation. We worked with a client recently that were seeing lots of problems with their defect management. And they knew, I mean, it was a source of pain. They didn't know is how big of an efficiency problem it was. And we went in and we measured it. We've estimated using their data, and they agree with this estimate, that the waste is probably somewhere in the neighborhood of 10% of their overall software engineering budget per year, and that software engineering budget per year is $1 billion. So, you know, do the math. That's $100 million in waste, and that's a lot. That's a lot of money that can be saved. So, you know, once you start to measure these inefficiencies, that really gets people's attention, because management will look at that and say, whoa, my God, how much money can we save? Now, in terms of like how to measure that for testing, you want to look at, you know, opportunities to improve. You know, look at cost of quality. This is something I don't have time to explain in any level of detail now, but if you go out to the RBCS website, look at some of the articles or presentations that have to do with return on investment, testing return on investment. Take a look at those. They'll describe how to actually quantify cost of quality, and you know, that's how you can measure efficiency. And again, these kind of simple techniques, the ones that I discussed in my books and in this webinar and in the discussion about cost, quality, and so forth, it can be used to identify, using simple math, potential savings of again, you know, tens of millions, potentially even hundreds of millions of dollars. Okay, well, I thank you all for your questions. We're got a lot of good questions this time. Again, more than we can always get to. Always happy to take questions subsequent to be posted on the blog via an email to info at rbcs-us.com. Good questions will get popped up on the blog, and we'll probably link to the recorded webinar. But to close down this session, let me tell you a little bit more about the resources that are available through RBCS. We run these free webinar sessions once a month, so you can sign up on our website, rbcs-us.com. You'll also get an invite now that you've attended one of these webinars, at least unless you were to ask us to stop sending you invites, in which case we will. If you would like a special webinar presentation for your company only of this webinar or any other topic related to testing or quality, contact us via the email I just gave you, info at rbcs-us.com, or via our website. If you don't already receive our regular free newsletter, you can sign up at rbcs-us.com. By signing up, you will get valuable discounts on consulting and training services, along with a regular newsletter that includes a featured article on software testing and quality, such as the article about risk-based test results reporting that Atsushi Nagata and I co-wrote. It's in the most recent one. And it also includes news about what RBCS and its partners are doing lately. You can follow us on Twitter at twitter.com/RBCS and on Facebook at facebook.com/pages/RBCS-INC. Remember to check your email over the next couple days. You might be the lucky winner of a free e-learning course from RBCS. Simply by attending this free event, you were registered. The drawing is completely random. Check out my blog, rbcs-us.com/blog. Feel free to post comments on anything that's out there, or email me, info@rbcs-us.com, if there's a topic that you would like to discuss, including any sort of follow-on questions on this webinar. Finally, check out our digital library with recordings of these webinars, podcasts, and videos. You can subscribe to our podcast via iTunes by entering RBCS Podcast into the search string in the iTunes Store. And you can see the videos and recorded webinars by subscribing to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community because at RBCS, we're a not-just-for-profit company. This concludes the webinar. I'd like to thank everyone for joining today and for asking such stimulating questions. Always great to have a good active session on these evening ones. And thanks for showing up. I look forward to seeing all of you guys next time. Good night.